We are going to talk about the process that is advanced oxidation. The term advanced oxidation in a general sense is a set of chemical procedures that are designed to remove the organic pollutants in the water and wastewater through reactions with dominantly hydroxyl radicals, and it can also be defined as a set of emerging chemical procedures which can remove or exclude the soluble organic effluents from the water or the soil or the wastewater. This process is generally used for contaminants from water through out of several types of industries like petrochemical, plastic, chemical industries, and basically there are various types of advanced oxidation process like radiation, photolysis, photocatalysis, sonolysis, electrochemical oxidation technologies, phenton base reaction, or you can say the last one or not the least one, it's the ozone base process. And it can also be used for disinfection to remove the microbial infection from the water, and it can target a lot of other species or pollutants in the water. It can also remove a traceable amount of getting pollutants from the water or heavy metals. Now let us go to what extent the advanced oxidation, or what are the process mechanism of advanced oxidation. It has been applied in a number of fields, and it can eliminate organic compounds from aqueous phase, and it can due to the reactivity of the OH radicals, it can react with almost every the water pollutant, and it can also be applied not only to remove the organic contaminants but also a traceable amount of inorganic pollutants. Some heavy metals can also be removed in the form of precipitate, and this is the mechanism. First of all, there would be a formation of strong oxidants, that is hydroxyl radicals, and these radicals or oxidants would be reacting with the organic compounds in the water that would lead to the formation of biodegradable intermediates, and these intermediates will be reacting with the oxidants, and then it would be referred, these reaction with the oxidants will be referred to as mineralization or breakdown in the form of water, carbon dioxide, and inorganic salts. Now AOPs can also be applied in pre-treatment stage to enhance or upgrade biodegradability, and also it reduces toxicity, followed by the biological post-treatment. And this is the typical diagram of the advanced oxidation setup that is available in a laboratory. This is the device called as CE584, and this is from the company called GUNT. And this, you can see the typical setup is, the A is the falling film reactor, the B is the raw water tank where you will put your the water to be treated, and then we have in the center we have a UV lamp which intensity is around 254 nanometers, and B is the pump, and this V1, V2, V3 are the valves, and T is the temperature sensor, and F is for the controlling the flow rate. And you can see the process description. So this is a batch process, this is discontinuous, and at the center we have the UV lamp. So this is basically going to irradiate or irradiating the water with the UV light. This will help in the formation of hydroxyl radicals. So we will be using the hydrogen peroxide as the oxidizing agent, and these type of reactors, in which whole, can also be called as a falling film reactor. And then this is the switch cabinet from where you are going to turn on the machine. At the end we have a plug, so the pump will supply the water from the tank to the upper end of the reactor, and then here the water flows into circular channel, and from the channel the water then flows to the overflow edge and then downward. So this is a kind of a loop process or circular process, and the UV lamp is in the center. So this is a pump, and this is not a slurry pump, so we have to use the treated water or the secondary water, and these are different kind of valves as we saw in the upper portion of the diagram. And this is my three-way valve, or we also call this as a sampling valve, and this is the rotameter which is used to control the flow rate. So you can go up to 200 liters per hour. Normally we set the flow rate to 50 to 100. That 200 liter is the maximum limit, and T is the temperature sensor. So temperature sensor, you can see the reading on the cabinet in the form of degree Celsius. So you have to connect first of all the switch cabinet to the main power supply. Then you can turn on the device, and then you have to make sure all the valves are closed, none of the valves are open. Make sure the sampling valve V2 is set so that the water flows from the reactor. It has not to be in the open side. Usually we open it when we want to take the sample. Then we have to remove the tank cover, which is here mounted on the top, so that we could fill the the raw water that has to be treated by the advanced oxidation system. And then we have to fill around 10 liters of the water, so that the temperature sensor, which is here, is fully submerged. And then we have to turn the UV lamp on. We cannot directly turn on the UV lamp. First of all, we have to do these procedures. Then we would turn on the pump with the we have not to run the pump dry, and then we have to also check there is no leakage. And then we have to wait for around that film of water so that it passes through the falling film reactor. Then we have to also check the temperature is displaying or not. Okay, after this we can turn the pump and the UV lamp off, and then at the end we have to empty it. Okay, now for if the UV lamp is not being used for a longer time, we have to remove it, and then we have to pack it. And these are the chemicals that we are going to use. So it is hydrogen peroxide, then we have a UV lamp, and a lot of parameters can be analyzed. Turbidity, the COD. If we are going to treat, suppose for this tryout, we are going to use it for the remedy or oxidation or remediation of the dye pollutant in the water. So we are going to basically measure. First of all, we are going to add the catalyst, then we are going to add the oxidation. So we make sure that there is adsorption, or there is oxidation, or there is a catalysis process going on. And the third step, we have to add the hydrogen peroxide and the catalyst, and we will be running this system for around 20 minutes to 30 minutes. And then we would be running the lamps so that there is photolysis, and then we would be running the lamp with the lamp, and then we would add a catalyst or an activator, and then you will add the H2O. This will be comprises the whole process as advanced oxidation. And then we will run for around 30 minutes, and then we will see in terms of kinetics. We have to take sample every 5 minutes, so that we can see that with the the concentration is reducing or not, and then we can plot our results. So this is for the description of the advanced oxidation system we have. So in this next video, we would be making the full video about the how we would plot, and how we would and we will see how the system is performing, or also we will see the efficiency of our system.